Okay, we have question 4 on paper 1 from 2023, and it's a small angle approximation question. So it says the curve C has the equation y equals f of x, where x is a real number. Given that f dashed of x is equal to 2x plus a half cos x, and that the curve has a stationary point x with x coordinate alpha, and that alpha is small. Use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. Okay, so we've got our expression for f dashed of x, and we know that there's a stationary point. So that means that f dashed of x is going to equal 0. So we can put the f dashed of x equal to 0 as our first step. Now in the formula booklet, the good thing is we're given the small angle approximations. You can see that we're given that cos theta is 1 minus theta squared over 2. So in this case, our cos x is going to be replaced by 1 minus x squared over 2. So that's fine. So now let's put in when x is equal to alpha. So when x is equal to alpha now, we're going to get 2 alpha plus a half times 1 minus alpha squared over 2. So expanding the brackets, a half times 1 is a half, and a half times by alpha squared over 2 is alpha squared over 4. So we've got that expression, which I'm just going to times everything by 4 now, multiply everything by 4. That gives me 8 alpha plus 2 minus alpha squared. And then because I don't like having a minus there, we're going to take everything over to the other side, or multiply it all by minus 1. So that gives me this quadratic equation, alpha squared minus 8 alpha minus 2 equals 0. And when I put that into my calculator, I get 2 values. I get one of them is alpha is 8.264, and the other one is alpha is minus 0.242. So this one is too big because it's a small angle approximation. So therefore, this is the correct value for alpha to 3 decimal places. Okay, the next bit of the question, what does it say? It says the point P with coordinate 0, 3 lies on C. Find the equation of the tangent to the curve at P, giving your answer in the form y equals mx plus c. So we need 2 things in order to find the equation of a line. We need a gradient and we need a point on the line. So first of all, we've got a point on the line. We're told that P has coordinates 0, 3. So we just need to find a gradient. So let's have a look. So we're going to use our f dashed of x formula, and we're going to sub in the x coordinate of the point P. So we're going to sub in the x coordinate, which is 0. So we have f dashed of 0 is going to be 2 times 0 at a half times cos 0. Cos of 0 is 1, so f dashed of 0 is a half. Okay, so that means we have our tangent has a gradient of a half. So we write down y equals mx plus c, and we're going to sub in the point 3, 0. So y is 3 when x is 0. We have a gradient of a half, and from that we can work out what c is. So c is 3, so therefore the equation of our tangent is y is equal to a half x add 3. I hope you found that helpful, and I'll see you in the next video.